Funding for this program is made possible by the Corporation for Public Broadcasting, Louis B. and Louise Hirschfield Coleman, Sue and Edgar Wackenheim III, and contributions to participating stations. Coming up, technology gives adrenaline junkies a new outlet.
Here, you're able to race aggressively head-to-head in a really exciting format without the risk of hurting yourself. It's all the fun of competing and racing without any of the physical risk.
And the bionic man and woman are no longer the stuff of science fiction.
It's absolutely transformational for wheelchair users.
Exploring the frontiers of science. Probing cutting-edge technologies. Seeking answers to the big questions. Welcome to SciTech Central. Drones are becoming ubiquitous, but they're often viewed by the public with fear and skepticism. A passionate group of Central Florida racers are integrating miniature technology with these small flying machines to create a new sport. And they want to share the fun.
MultiGP is a grassroots racing league. Whenever you are looking to race FPV, race multi-rotors, or drones, like a lot of people like to call them, you need a place to do it. And so that's what the grassroots effort of MultiGP is focused on. It's our goal to find a place in every city, a field in every city, and put coaches and train people in those fields so that way we can have a real sport occurring all over.
As of October 2015, MultiGP has 140 local chapters around the world and over 3,000 registered pilots.
This sport is growing. We started about 3 months ago in our group with about 5 or 6 guys. It was just a couple of friends that wanted to start the group. Now we have almost 150 members, and every day there's always somebody new getting on it.
At a recent event in Orlando, pilots competed to improve their national rankings.
So as a pilot, you come to their official monthly race if you want to be ranked on their leaderboard to determine how good of a pilot you are. By participating, you gain points that go to the overall score that you would have if you participate in each of these events.
The MultiGP website lists upcoming races. It also provides pilots key information they need to compete.
They register, and it gives them a frequency. And that frequency is what they use to fly. And then I tally up the points, and at the end of the 6 months, it also gives them a total of points for the championships.
Like all competitors, MultiGP pilots are constantly searching for ways to gain an edge.
So part of racing is studying the track and looking at your machine and saying, okay, how can I tune this machine for my next race? What will I need? Speed? Will I need agility? That stuff you have to take into consideration when you're gonna go fly. And it's part of the tuning process. If you're, let's say today you're racing in a track that's a really long track with minimal turns, you can use really big motors and you'll be able to have a lot of speed.
The track was really interesting. They actually did an upper raised gate where you had the opportunity to shoot a small hole and save some time, so that was really exciting.
It's a race car, so you always have to make the fine adjustments to be a little bit faster than the other guy, which would be changing the propeller, changing the motor, or tilting your camera a little higher as you get better.
I have it written down.
The people who are in this sport right now, this is the early adopters. They're technology people, they are computer people, they're smart people. It's a bunch of nerds at a park, really. That's how I like to refer to it, but it's a great culture of people who create.
A small video camera on the drone literally gives pilots a bird's eye view. While essential to the sport, remotely controlling a flying vehicle this way is definitely a learned skill.
Racing a multi-rotor is similar to real racing in that you have a course, you're trying to follow that course, and you're trying to go as fast as you possibly can. But what's different is it starts off a little disorienting for most people. This is a set of FPV goggles. It provides a real-time video feed to the camera that's on board. So this is our link to being in control. Most of the time you start off flying around, you're trying to get a feel, how high am I? Am I going up? Am I going down?
The first time I took off, your equilibrium is so confused. You're just in a different plane. You're turning and banking, and your body's sitting still. It's really awkward. It takes a while to get used to it.
You have to operate the throttle, which makes you go up and down. The ailerons, which makes you bank left and right. The pitch, which makes your nose go up or down. And the rudder, which rotates the quad around the horizontal axis. All those 4 controls have to be used at the same time. And it takes a lot of patience, a lot of practice to be able to master those 4 controls. And there is no substitute for stick time. The more you fly, the better you're gonna get. It's not always about how fast you are, it's how good you fly through the track.
As with any racing sport, the thrill of speed is a big attraction, but multi-GP boasts a huge advantage over others.
As you get older, you get wiser, you start to mitigate risk. You're less likely to put yourself at harm. Here, you're able to race aggressively, head-to-head, in a really exciting format without the risk of hurting yourself. It's all the fun of competing and racing without any of the physical risk.
I used to ride sport bikes. I had a couple bad accidents on it, and I get the same kind of adrenaline rush racing this, and I get to come home in one piece, so mission accomplished.
The Robotics Association at Embry-Riddle is the only student organization in the world, actually, that competes in all of the major AUVSI robotics competitions. We cover air, ground, sea, underwater, and even with our NASA competition, space. This organization is completely run by the students. We have the student officers and then student team leads for each of the various teams.
That's one of the things I love about this. We have projects in everything. When I came in as a freshman, I got my hands right in. First week of my freshman year, I was working on projects and doing things that mattered and that I learned a lot from. The quad itself was designed in-house here, 3D printed, which means it was built from the ground up here. It's completely student designed, and it's for our International Aero Robotics competition. Hold it right about there. So you can see, I'm not controlling it at all. It's completely autonomous.
Right here I have our last year's robot for NASA's robotic mining competition. It's a competition held down at Kennedy Space Center every year. I actually learned quite a bit just from starting to work on it. Anytime you get your hands on any of these projects, you're going to be learning while working on them, but also from all the classes I've taken, you can definitely put everything you learn together into one system.
It's a great learning process to actually go into the competition and then working on these projects. You know, building it up, you always go through a design phase where you come up with the ideas, the concepts of what you want to implement, find what doubt is feasible, and then just go out and do it and make sure that your system works and hopefully better than last year.
Only a third of bachelor degrees earned in the U.S. are in a STEM field. Hoping to inspire future scientists and engineers, RoboFest in Tampa, Florida, challenges students to put their programming skills to the test.
So RoboFest is an autonomous robotic competition. That means that no remote control, no wireless devices. All the programming has to come from the child's head and program it into the computer. And at the day of the competition, press on and back away.
Emma Alaba is the director for the Tampa Bay Regional RoboFest competition. Every year, this event determines who goes to the international competition in Southfield, Michigan.
It's mainly to help kids get prepared for the future, and which is STEM, science, technology, engineering, and math.
Today, both students in middle and high school compete. This organization provides training for anyone who puts together a team.
We take them from 0 to 100. Rookies who don't know how to, can't even identify a Lego, don't even know what a 32-bit processor is, or a sensor, or a light sensor, or a touch sensor, because those are the things that makes the robot happen to do what you need to do.
There are two competitions here. Exhibition competitors showcase a unique and innovative use for robots, while game competitors have to navigate around obstacles and knock down pins.
So once the competition starts, the kids are on their own, because now they unveil the unknown. Now the kids have to actually program the robot to accomplish the competition with the unknown factor that they didn't know before.
For the game competition, students are given 30 minutes to take this previously unknown factor and make last-minute changes to how their robot is programmed.
That's to ensure that the child or the student did the work.
One of the teams at this year's competition is St. Pete Beach LTs. Team captain Kayla Oates put in a lot of hours to get here today.
Well, when we first started, it seemed really easy. Like, you're gonna get through it really fast, but as you get more into it, there seems to be more problems every day. We stayed a lot of late nights trying to fix the robot.
Coaching the students requires a hands-off approach.
Basically, the kids are supposed to do most of this by themselves, so I'm a coach, I'm just a mentor, trying to point them in the right direction.
The student teams combine engineering and computer programming skills to accomplish the task.
So you literally have to program your robot to accomplish the mission. So you got to use your brain. And that's the whole idea of RoboFest. Make them use their brain.
In the exhibition competition, students create a real-life application for a robot. The team then demonstrates their work for the judges.
I want the kids to know how to own their name, stand up and talk. You need to be able to explain to the judges what they're looking for, because that's going to determine whether you win or lose based on what you say.
These young people from Eastlake Middle School created an ingenious device for training.
We built a ball thrower for kids and adults who have prosthetic hands. It trains their muscle memory, because with the prosthetic hand, once you get it, you're not like, oh, I can pick up a water bottle instantly. You have to train it and practice to make sure that it works fine.
And Team Embedded Logic created a robot to help dispense medicine.
We've got people with disabilities with arthritis, and maybe they can't open bottles, so it dispenses medicine for them.
We had to start with some new programs, and I used a different one called Robot C. And it's a little bit harder because you have to completely write it with numbers and letters. And then we made some of that, and we had adults help us because we didn't want to cut off our fingers with saws. So yeah, it was a pretty fun experience actually.
The judges score the exhibits as well as the games. The MC keeps everyone engaged, while coaches and parents cheer on the competitors.
What does it take to put a project on like this? Lots of volunteers, lots of volunteer hours, and the tenacity to hang in there and get it done, no matter what it takes.
After 2 rounds of games and exhibitor presentations, everyone anxiously gathers for the results.
Well, it wasn't our best round, I can say that. That's why I didn't think we were going to win, because it wasn't the best that we could do. And then they said our name at first place, and that was just a really big shock.
It's just interesting seeing my software translate into the world to make it control robots and things like that. It's rewarding seeing it do what I try to get it to do.
Plant High's coach, Robert Taird, teaches biology, and he leaves all the robotics programming to the students.
Adam's pretty much self-taught. He knows way more about programming than I do. So, most of the time I'm bouncing ideas off of him more than he's bouncing ideas off of me. And he'll tell me whether or not it's possible.
I think it's really fun, and it's a good opportunity to learn and get to know other people who might be a good relation in the future, but it's a lot of work, so buckle up.
I would tell my friends that they should join, because it's really fun programming the robots and actually seeing it work and compete against others.
The RoboFest Tampa Bay qualifiers was a big success, sending some students to international competition in Michigan and raising the bar for all who competed.
Kids become awesome when they do robotic competition, and especially when they do a RoboFest robotic competition. I want every kid to be empowered. It's about being well-rounded in whatever life throws at you, So you become a thinking, fulfilled citizen of today's world.
Want to satisfy your scientific curiosity and be on TV at the same time? Send us a video question for our Ask a Scientist feature. Here's an example.
My name is Kelly. I'm from Orlando, Florida. I know coral reefs are important to the health of the oceans, but I would like to know why.
Go to our Facebook page to learn how to submit your video.
There's a whole field of research focusing on creating technology based on biology. It's called biomimicry, and it's particularly useful in robotics. If you've ever looked at a light hanging outside on a warm summer evening, you might have noticed that bugs tend to swarm around it, like bounce off and then pick themselves up and do it all over again. Well, that's what the Airbur does. It's housed inside of a big, flexible frame that is designed to bump into walls and stuff and survive. If it does fall out of the air, 4 legs extend to get it upright so it can start flying again. In this way, it doesn't need complex systems to get around. It just bumps around, but eventually makes its way, like those bugs on your front porch.
Bionics, incorporating electromechanical parts into the human body, has long been a staple of science fiction stories. Now, the future is here, and paraplegics are walking.
From driverless cars to automated vacuum cleaners, we hear a lot about how robots are going to take over everyday tasks. These odd-looking contraptions in a university lab could provide a clue about the next frontier in the robotic revolution.
When we think of medical science, it's usually test tubes and white lab coats that come to mind. But here at King's College London, researchers are exploring ways that robots can improve human health. From bionic limbs to improved mobility to surgical devices of the kind being developed here, the worlds of biology and robotics are coming together.
High-tech instruments and probes are already a common feature of the hospital operating theatre. But more sophisticated devices could eventually allow surgeons to carry out procedures with greater precision than is possible today.
Here in the Center for Robotics Research, we are taking inspiration from the octopus and try to create soft robotic devices that can be used for minimally invasive surgery. So here we are developing these devices, and you can see the system moving here in the background. So it is a soft robot, and that makes a radical step from what we have seen in the past. We are moving away from the usual approach of rigid robot arms, but not only soft, can be stiffened if required, very much like the biological inspiration we take from the octopus.
Sensors are being developed that will help guide surgeons to cancerous tissue, and some people believe such procedures could one day become almost entirely automated.
So create a robotic device that effectively works on the push of a button. Many issues, of course, that need to be resolved because the intelligence of the surgeon is really required to manage the operations as they're done today. So that is not just moving joysticks about, but also making decisions on where to cut, where to move to with the robotic device.
Robotic surgery is still in its early stages, and commercialization of these devices is years away. But in other areas of healthcare, the bionic age has already arrived.
And then once I'm standing, it's extremely manageable. It's just a very simple control setup.
This is a robotic walking device developed by a New Zealand company called Rex Bionics. It allows paraplegics to stand up and move on their own feet.
Well, it's absolutely transformational for wheelchair users. The sensation for them of being able to get up to their full height. I have seen wheelchair users being told by their mates, who they'd known for 20 years, I had no idea you were so tall. Secondly, they're able to return to work. Jared, our engineer in our plant in New Zealand, is able to spend all day in a Rex and do work that would not otherwise be possible. So we've done the technology push part of it. The robotic technology has now been invented to replicate the human gait and all the tremendous complexity that there is in the human gait. But now we are beginning to see the medical benefits. They are at higher risk of cardiovascular disease and diabetes, and if they can stand and be mobilized, it is very well documented that these problems are significantly reduced.
The company listed on London's AIM stock market last year to raise money for an international sales push. The £90,000 price tag will be an obstacle for many, but Rex is aiming to gradually lower the cost as economies of scale kick in.
It is expensive at the moment. There is a lot of technology in there, but like a lot of nascent technology, there is lots of potential to bring down the cost. But first and foremost, we need to get people to accept and understand and embrace the technology and its value.
A cheaper, more basic version of this technology has been developed by a Californian company called AlterG. Its £13,000 bionic leg is used to aid rehabilitation after injuries or strokes.
Okay, so press go and you're ready to stand up and start walking.
Okay. Well, that feels strange. It takes some getting used to, right?
Yeah, but it'll soon work out your own gait. So the concept behind the bionic leg was to actually look at a way of we could give people with weaker limbs extra strength to allow them to sit and stand and to walk normally.
Some futurologists envisage a day when technology such as this could even be used by able-bodied people to enhance physical capability.
At the moment we're at a stage where we're looking at how we actually help people to ambulate where they've had an injury, but you can quite see how in the future maybe there will be other models that would actually allow people to have greater strength, greater endurance and those kind of things. Everything is possible with the way technology is going.
This piece of kit is a long way from the devices being developed at King's College London, or indeed the cyborgs beloved of science fiction writers. But it shows how bionics are already having an impact on healthcare, and that will only increase as robots take an ever bigger role in human life.
That's all for now on SciTech Central. Thanks for watching. Join us next week for more stories from the frontiers of science and technology. Funding for this program is made possible by the Corporation for Public Broadcasting, Louis B. and Louise Hirschfield Coleman, Sue and Edgar Wachenheim III, and contributions to participating stations.